Hello, this is Dr. Caleb Chen, and this is our statistics series. Today we'll be focusing on numerical measures, and primarily we will be talking about the measures of center, measures of spread, and in any data distribution. When we look at the data distribution, you want to note about the center of the distribution, the spread, and also the shape of the distribution. And oftentimes we'll have to use some kind of graphical displays to help us determine the shape. And for instance, is it symmetrical or asymmetrical? So these are the three characteristics of any data distribution. Well, with that in mind, we're going to be looking at, first of all, the center of the distribution, and we'll make it one video clip of its own. So of the center, we typically use mean as a measure, or the arithmetic average, and then median is another one, or mode. So these are the three common measures of center that tells us, well, what is the typical value? The typical value out of a data distribution. Well, the average could be a good one if there are no extremely small or large data points. And then we have median if we have some extreme values embedded in the data set, while median is not affected by any outliers, so to speak. And mode is the most frequently occurred value of the data series. So how do we differentiate one from the other is something that you'll be learning in the classroom. There's one more measure that is going to be the geometric mean, GM, geometric mean. There are two calculations, but we'll focus on the calculation right here. It allows us to look at, say, the average growth rate over time when you only have a couple of data points. Let me use the example. I came here to the Spring Arbor University in 1993, and the student population back then was about, say, 800 students on campus. Today, 21 years later, 2014, we have roughly 1,600 students on campus. You can see, our population, student population, doubled over the period of 21 years. But can we say because it's 100% growth rate over 21 years, and we divide by 21, therefore the average growth rate is about, say, 5%. I just rounded up. So if it's 20, then it's about 5. But the geometric mean, the equation would allow us to actually look at what we call the compound interest or compound growth rate. In this case, what would be the percentage growth? It would be less than 5%. It might be the 2.5%, it might be 4%, depending on how quickly we're growing. So we'll look at the equation, and with the help of some other tools, such as the calculator, we'll be able to calculate that. So let's set up the equation. GM is equal to taking the nth root. So n of the nth root of this ratio, the ending value. In this case, that would be the 1,600, and the beginning value is this ratio, which we take an nth root. So it's not just the square root, but it's the nth root, and we minus 1, subtract 1 from this equation, and then we get the percentages. So in our application is going to be 1,600 divided by 800, and the n is the number of years in between. So that would be 2014 minus 1993 over 21 years. We have grown 100%, and that will be minus 1. So this would be basically the value 2 to the n is 21st root minus 1, And in your calculator, there are a couple ways to do that, and we would show you how in class. And but right now, if you look at this example here, it says during the decade of 1990s and into the 2000s, Las Vegas was the fastest growing city in the United States. And we look at the population. As of 2007, the population size was was more than 500,000, and yet in the 1990s, which was 258 to 95, and slightly more than a quarter of million. So we look at the time apart, and is actually from 1990 to 2007. So the 17 years apart. So we take the 17th root of this ratio, and which turns to be 1.0457 minus 1, and we know that the growth rate is 4.57% each year. For us to go from, say, 1990 of a population, say, slightly over a quarter million, to 2007, 17 years later, that it has grown to the more than the 500,000. So this is the geometric mean, and along with the other three measures, mean, mode, and also the median, we would be able to describe the center of the data distribution.